Hi everyone, today we're going to discuss complex fractions. In the Do Now, I have a complex fraction. How would we define a complex fraction? Well, I'll put the definition here on the side. Definition: a complex fraction is a fraction whose numerator or denominator or both are fractions. Okay, so how would we simplify this? Take a minute and think about how you'd simplify it. All right, well, one thing we could do is get a common denominator here of 16 in the numerator and a common denominator of 4 in the denominator. So this would be 16 plus 9, and the other one would be 4 minus 3. That would give us 25 sixteenths all over 1/4. And this means division. So we could rewrite this as 25 sixteenths divided by 1/4, which is 25 sixteenths times 4. And of course, the numbers divide through here. This goes 4 times and this goes once. So the answer is 25/4. And that's our final answer. But there's another way to simplify a complex fraction that is used more often in higher mathematics. And what we do is we find the least common denominator of all the denominators in the complex fraction. So what is the least common denominator of 16 and 4? 16. So what we do is we multiply by a form of 1, 16 over 16. Okay, so we're going to multiply the numerator by 16 and the denominator by 16. But if we do that, we have to distribute. So we have 1, let me just change the color again, 1 plus 9 sixteenths times 16 over 1 minus 3/4 times 16. We distribute. And when we distribute, notice the little denominators that appear should disappear. So when we distribute, we get 16 plus 9 sixteenths times 16, which is 9. And then 16 times 1 is 16, minus 3/4 of 16. Well, 4 goes into 16 4 times, so 3 times 4 is 12. And when we simplify that, we get 25/4, which is the same answer as we have gotten above. All right, so let's summarize the two ways to simplify a complex fraction. So the first way is to add or subtract the fractions in the numerator and denominator so that we get one fraction in the numerator and in the denominator. In other words, combine the fractions in the numerator, combine the fractions in the denominator, perform the indicated division, factor, and simplify. And this was method number 1. Now, method number 2, which is what I'd like to focus in this video today, is to find the least common denominator of all the fractions within the complex fraction. multiply the complex fraction by the least common denominator divided by the least common denominator, which is a form of 1. That's a 1. By the least common denominator over itself. 3. Distribute and simplify so that the numerator and denominator of the complex fraction are polynomials. And then factor and simplify if necessary. So let's try another one together, and I'll call this number 2. Okay, so the problem I wanted to look at is 1 plus 2 over x divided by all over 1 minus 4 over x squared. Let's try method 2. Let's take the least common denominator of these denominators. And the least common denominator of those two is x squared. So we multiply the top and bottom by x squared over itself. Now remember, we have to distribute. So when we distribute, let's see if we could do this all in one step. In the numerator, we get x squared plus, now x goes into x squared x times, so we get a 2x here. And when we distribute in the bottom, we get x squared minus 4. Now let's factor and simplify. So we could factor in an x in the numerator. We could factor the difference of two squares here. We see that the x plus 2 divide through, and the final answer is x over x minus 2, with the understanding that x is not equal to 2 or negative 2. All right, let's try another one. Number 3, a to the negative 1 plus b to the negative 1 over a to the negative 3 plus b to the negative 3. All right, so let's try to write this as a complex fraction. 1 over a plus 1 over b divided by 1 over a cubed plus 1 over b cubed. And if we take a look at all the denominators that we have here, a, b, a cubed, b cubed, the least common denominator is a cubed, b cubed. So when we distribute, these expressions should go in the numerators of each of the little fractions. So we have a cubed, b cubed over a plus a cubed, b cubed over b divided by a cubed, b cubed over a cubed plus a cubed, b cubed over a cubed. And then, of course, we could divide through one of the a's and b's here. This would be an a squared and a b squared. And the a cubes divide through to a 1. Oh, wait, I miswrote. It's a b cubed. Oh, wait, let me just erase that. B cubed. So then these divide through to a 1. So we're left with a squared b cubed plus a cubed b squared, all divided by b cubed plus a cubed. Now let's try to factor that. In the numerator, the highest power of a that we could factor out is a square, and for the b, a square as well. So we're left with b plus a. The denominator is the sum of two cubes, and we could factor that into b plus a times b squared minus ab plus a squared. And notice that these b plus a's divide through, and we're left with a squared b squared over b squared minus ab plus a squared. Now, it's understood that the restrictions are that a can't be 0, b can't be 0, and b cannot equal negative a, looking at this denominator here. And of course, this piece cannot equal 0 as well. All right, let's take a look at a few more. All right, let's try these two problems. All right, in the first one, we're going to write it in a complex fraction form. We'll change the negative exponents and write it this way. And the least common denominator of x, y, and xy is just x times y. So we distribute this, and this. Here we don't distribute, we just multiply the two fractions. So we get xy over x plus xy over y divided by x squared minus y squared over xy times xy. And this is where denominators should clear. So notice the x's divide through, that's a form of 1. Here we have a 1, and these two divide through. So we're left with y plus x all over x squared minus y squared. We could factor that as a difference of two squares. And these divide through, of course, it's a form of 1, commutative property of addition. And we have 1 over x minus y, And it's understood that x cannot equal 0, y cannot equal 0, and x is not equal to y, or x is not equal to negative y. These are all implied in that fraction. Okay, now in number 4, we have 4 denominators. X squared again, and x minus 2. And the least common multiple here would be x squared times x minus 2 over x squared times x minus 2. Now, when we distribute, we really have to be really careful. Here, I'll put these in the numerators again. 3x squared over times x minus 2 over x minus 2x squared times x minus 2 over x all over 3x squared times x minus 2 over x minus 2. And this one is x squared times x minus 2 over x squared. And notice what divides through here. Oh, this one's an x squared. That's why I thought I didn't do it right. Okay, so what divides through in the first fraction is an x. Let me just do that in green. In the second fraction, the x squareds divide through completely, and here. And the x minus 2's divide completely there. So we're left with 3x times x minus 2 minus 2 times x minus 2, all divided by 3x squared minus x minus 2. Oh, excuse me, this should be a plus. This should be a plus, otherwise it changes it. Now, in the numerator, the greatest common factor is x minus 2. So let's factor it out. And we're left with a 3x minus 2 in the numerator. The denominator could be factored into 3x minus 2 times an x plus 1. Let's just check that. Negative 2x plus 3x gives us positive x. It works. And we can divide through here the 3x minus 2's. And our final answer is x minus 2 over x plus 1. And the understanding is that x cannot equal negative 1. X cannot equal 2/3 to make this denominator 0. X cannot equal 0. And x cannot equal 2. And those would be the restrictions. Let's try one more. Now, when we have a complex fraction with binomial denominators this way, it's a good idea to start factoring it right away. So let's do that. And we have 3 over 2 times x minus 1 minus 1 over x plus 1 divided by 1 over x minus 1 plus x over x plus 1 times x minus 1. And when we factor the denominators here, it's good for two reasons. One, we could get the least common denominator very easily in factored form. And two, it's easy to divide through. So the least common denominator here would be every factor, 2 and x minus 1 and an x plus 1, the product of those three. Because each of those prime factors are raised to the first anyway. So let's see if we could do this without writing all the work like we did in the other pages. We distribute this to this fraction and to this fraction. And note that when we do that, the 2 and the x minus 1's drop out, so we're left with 3 times x plus 1. Oh, that should be subtraction. Okay. In the second one, the x plus 1's divide through, so we're left with 2 times x minus 1. In the bottom, the x minus 1's divide through, so we're left with 2 times x plus 1. And in the last one, the x minus 1 and the x plus 1 divide through, so we're just left with a 2x. Now let's work this out, distribute and combine like terms, and see if we could factor. So we get 3x plus 3 minus 2x plus 1 plus 2, because we're distributing here, over 2x plus 2 plus 2x. And combining like terms, we're left with x plus 5 over 4x plus 2. Even though we can factor this, we cannot divide through anyway, so we'll leave our answer like this, with the understanding that x is not equal to negative 1/2, which makes this denominator here 0, 1, which would make one denominator 0, negative 1, and 1, negative 1, and I think that's it. I think we covered all the denominators. Okay, that takes care of complex fractions. Usually in the books you wouldn't see these restrictions, but it's good to be aware that there are restrictions. Have a great day. Bye.